Welcome back to the channel. This is the Earth Science Classroom. This video is on ecosystem tolerance and looking at defining what this term means in terms of the environment and how these ecosystems function and what happens when the area or ecosystem goes beyond its tolerance into areas where there is change or alteration to both the biotic and abiotic components. So let's check it out. This is the Earth Science Classroom. Ecosystem tolerance is a general term given to an ecosystem whereby we can look at its functionality, its dynamic system, and its stability based on certain limits that are specific to each ecosystem. Because every different ecosystem has its own level of niches, biomes, limiting factors, nutrient cycling, flora, fauna, soil type, soil thickness, climate. All these things go into the production or maintenance of an ecosystem. And the tolerance is that general term looking at what happens if any limits or any changes occur to that ecosystem, how resilient or how the ecosystem will be affected is quantified in this term tolerance. And we can use this because the effect of humans on ecosystems. So this bell curve is pretty straightforward. You have on the x-axis, you have the level of tolerance, a gradient for the environment based on ideal versus non-ideal as you go to the far left and right of the chart. And on the y-axis going vertical, you have the size of population or the size of the ecosystem, the complexity of the ecosystem, the ability to hold a high level of biodiversity on the y-axis. So as you see in the center of this bell curve, you have the optimal conditions where you have the majority and maximum size of population of species, the highest carrying capacity, and it drops off quickly on either side based on this environmental tolerance or gradient. Now it's divided into three main zones or levels based on the different levels of tolerance for each ecosystem. Starting in the middle of the bell curve, the graph, we have the zone or level of optimal conditions, the area where the ecosystem is functioning correctly and working based on its flow of nutrients, based on limiting factors, based on holding all the capacity to have large numbers of biodiversity, and all these different limiting factors are working to produce a high carrying capacity, and the ecosystem is working as it should. It is tolerant to changes, and any change that does happen is within this optimal conditions will be dealt with and assimilated to maintain the flow and the stability and equilibrium of the ecosystem in question. Now this can change based on different ecosystems, based on different factors, but generally you have this amount of resilience that an ecosystem has when it's in this optimal condition zone or level, whereby things can happen, but it still maintains its optimal conditions. It has to be a large shift or a large disturbance to push this ecosystem out of this optimal conditions zone into what's called the stressed zone, or it becomes a level of intolerance where you've changed the ecosystem into something different. The next zone or level is the stressed zone. As I said before, this zone is when the ecosystem has been moved away from the optimal conditions. There's something happened or something has happened to that ecosystem to push it. The resilience has been pushed to a point where it goes over the threshold and moves into this stressed level of tolerance in terms of the environmental gradients. And this means that there is a reduction or a decrease in the amount of population size the ecosystem can hold, the carrying capacity. Now, it could be flora and fauna or a combination of both. Now, this change could be biotic or it could be abiotic. Could be a combination of changes that have pushed this ecosystem away from its optimal conditions. Could be human activity which has caused this. But it could take some time if left alone. If that change stops, it might take some time to then allow the ecosystem to go back towards or go back into its optimal conditions zone. In order for an ecosystem to be in this final stage or final level, which is called intolerance, which means that the functionality of the general ecosystem is failing, is being pushed beyond its limits. This could be the limiting factors, this could be the abiotic, biotic components, it could be a combination, it could be a disturbance, it could be human activity, but something is happening to this ecosystem that has taken it from the optimal conditions of functionality, of biodiversity and high levels of everything, a very healthy ecosystem, has moved it into the stressed zone where there's changes and levels of intolerance, and then into this final stage where this ecosystem is not functioning. It is not working correctly based on various factors, and the cause of this intolerance either has to be removed or reduced to then allow the ecosystem to revive, to respond, to rebound back, like in succession, where you have this disturbance and then it starts again with either the soil in secondary succession or with bare rock in terms of primary succession with the lichens and mosses and pioneer species. But that intolerance has pushed that ecosystem into a zone where it cannot function anymore. And this, in terms of environmental science, is very important because the stressed and intolerance zones are what we have to look at to see what is the cause. And if it's human activity is the cause, how do we respond? How do we remove that activity and that influence to allow this natural ecosystem to rebound back and go back to its optimal conditions? This is the Earth Science Classroom. Thanks for watching the video. If you liked it, please subscribe, like, and share. And if you want more content and videos on Earth Science, please check out my channel.